Hello viewers, I am Kausalya. Today we are going to solve the problem related with admittance parameter. The problem is obtain the Y parameters for the pi network shown. So here this is the given network. Again we are going to calculate the four different parameters of Y. So here what is the basic equation? The equation is I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. So in the previous video we had solved the same problem, right? Just by short circuiting the input port and by short circuiting the output port. Once you short circuit the input port, you will be calculating two parameters. Similarly, when you short circuit the output port, you will be calculating the remaining two parameters. But here, we are going to solve the same problem in a different way. Here, I had used nodal analysis. And finally, here also we are ending up finding the different Y parameters. So, let me show you how. So, here in the given circuit, how many nodes do you have? So what do you mean by node? Interconnection of two or more elements. Okay, the interconnection point of two or more elements is said to be node. So here, this is one node and this is another node. So totally for the given network, we have two nodes. Am I making clear? So first you see, so I am considering node 1. And respectively the current through the input port is I1 and the current flowing through this output port is I2. So now we are going to apply nodal analysis at node 1. So here to this node 1 how many elements are connected? Two elements are connected. So this is your node 1 and obviously this is your node 2. So we are going to write the nodal equations. So here, what is the nodal equation? That is I is written in form of V by R or V by Z. So here at node 1, you see to this node 1, this 4 ohm is connected. So here the value can be written as V1 by 4. Okay, V1 is the respective nodal voltage at node 1 and V2 be the voltage at node 2. If you want, just make a note of it, you can write it here. So here the value of I1 is given by V1 by 4 and again between node 1 and 2 I have a 2 ohm resistor. Since we are considering node 1, you have to write it as V1 minus V2 divided by 2. Right, because we are writing in the form of current. Okay, that is I1 is the current that flow towards the node 1. And the respective resistors which are connected are 4 ohm and 2 ohm. Here this 4 ohm is connected only with the node 1. So while writing expression you can write it as V1 by 4. And this 2 ohm is connected between node 1 and 2. Since we are considering node 1, here we have to write the expression as V1 minus V2 by 2. Right. So now as usual we are combining the similar terms together. So here V1 by 4 plus V1 by 2 minus V2 by 2. Here V1 is common. So when I take V1 outside, the remaining parameters are 1 by 4 plus 1 by 2 and this minus V2 by 2, it remains the same. So once you take LCM, here it becomes 1 plus 2 because here I have 4, right? So I am multiplying here by 2. So 1 plus 1 into 2 is 2. So 1 plus 2 which is 3 by 4. And here this term we are having only one V2 term, so keep it as such. So here it is minus V2 by 2 which is equal to I1. So now you see here we have V1 and V2 and here we have I1. So we can compare this equation with the standard equation. So what is the standard equation? Here you see, here we have I1 in terms of V1 and V2. Similarly, here we have calculated an equation, you see I1 in terms of V1 and V2. Right. So when you compare, this is your standard equation. So once you compare, you see V1 is here and in the place of Y11 I am having 3 by 4. So Y11 is nothing but 3 by 4, which is 0.75 mho, because here it is admittance. Similarly, when you compare these two parts, you see here it is V2, again here it is V2. So Y12 is minus 1 by 2. So minus 1 by 2, which is nothing but minus 0.5 mho or Siemens. Okay, you can write any one of the units. So here we have calculated Y11 and Y12. Now we are going to calculate Y21 and Y22. So here this is the given network and this is your node 1 and node 2. Now we are going to apply nodal analysis for node 2. So again, when you look at the node 2, you see how many elements are connected with node 2? We are having 2 ohm and 8 ohm. And again, this 8 ohm is connected only with node 2. But this 2 ohm is connected between node 1 and node 2. Therefore, you see by nodal analysis here the current is I2. So I2 is given by I2 is equal to V2 by 8 plus V2 minus V1 by 2. Here why we are writing it as V2 minus V1? Because we are writing nodal equations at node 2. So here node 2 should be written first. It should be given much more importance. So for the first term it is okay because this 8 ohm is connected only with this node 2. So here it is written as V2 by 8. But when you consider this 2 ohm, it is connected between 1 and 2. And now here we are writing nodal equations for this node 2. So here we have to write it as V2 minus V1 divided by 2. And again, now we are going to combine the common terms. So when you combine the common terms, what happens here? So V2 by 8 plus here V2 by 2 minus V1 by 2. So here V2 is common. Once you take V2 outside, the remaining terms are 1 by 8 plus 1 by 2. So here you have to take LCM. So here it is 8. So I want to make this term as 8. So I am multiplying by 4 on both the numerator and denominator. So here V2 into it becomes 1 plus 4 by 8. So 1 plus 4 is nothing but here it is 5 by 8. And here this minus V1 by 2 is written as such because there is only one term with V1. So again the same thing. Now we are going to compare this equation with our standard equation. So what is our standard equation here? So I2 is equal to Y21 V1 plus Y22 V2. So once you compare here, what happens? So here this Y in the place of Y21, that is you see here it is V1, right? So where is V1 here? Here I have V1. So what is the parameter? It is minus 1 by 2. So Y21 is, so here when you compare, you see obviously Y21 is minus 1 by 2. So Y21 is minus 1 by 2 which is minus 0.5 mho. And again here we are having V2, here also V2. So what is the parameter? It is Y22. So Y22 is 5 by 8 which is nothing but 0.625 mho. So here again we are getting the same answer when compared with the previous problem, right? That is, sorry, when we had solved the same problem using two different methods. Okay, in the previous video I had solved the problem by short circuiting the input port and output port. But here just by applying nodal analysis we had framed equations, and finally we are comparing the equations with the standard equations, and we are finally sorting out the different admittance parameters. Anyway, you can select any method to solve this problem. It is up to you to choose what method you want. Right, there is no restrictions to select your own method. So that's all. If you have any doubt, let me know in the comment section. Thank you.